In this video, I'm gonna briefly walk you through how to start building on Bsquare network. It is basically the same as how you would do on other EVM-compatible chains. So if you are already familiar with this kind of stuff, you can just skip the video and get right on hacking. For beginners, the general workflow may include following aspects. I'll just dabble in a few of them today, and here is just to give you a rough idea. Firstly, there are some technical choices you should probably keep in mind. For instance, what's the smart contract language you plan to use? Beginners should probably just go for Solidity, because it simply has way more learning resources and broader ecosystem. You should probably keep up a framework to work with, which may help you streamline various development tasks. Meanwhile, ballpark of your time will be spent on designing, implementing, and testing your smart contracts, like unit testing, integration testing, and probably some invariant testing as well. In addition, to improve user experience, you may also consider setting up some event syncing services to aggregate on-chain data for the front end to consume. And finally, the front end will interact with the contracts via API. It's also a good idea to integrate account abstraction into your dApp. In our case, since we partnered with Particle Network, you can simply integrate their BTC Connect SDK in order to onboard users with BTC Wallet directly. Now to start with, a couple of frameworks to choose from. Hardhat is usually a good place to start with for JavaScript or TypeScript developers. As you gain more experience, you may start tapping into Foundry as well, which provides many advanced features, such as fuzzy testing and EVM cheat codes, enabling you to write tests and scripts directly in Solidity without the hassle of context switching. For the remainder of this video, I'm just gonna stick with Hardhat. Now let's move on to scaffolding our new project. Here I'm using Yarn as my package manager, install Hardhat as dev dependency, run Hardhat any command, and choose TypeScript with VN as the template. Then we'll arrive at this project structure, where you'll have a contract folder containing a sample log contract, an ignition folder containing deployment scripts, which we'll cover later in the video. Meanwhile, testing scripts are located in the test folder. The next thing we'd like to do is to modify the Hardhat config. Firstly, let's update the Solidity entry, where we simply add optimizer settings. Then we'll add network entries, where we configure update settings for Bsquare network and testnet. Also the Etherscan entry used for contract verification. And optionally, you can also install .env or .envflow package, so that you can maintain secrets locally in .env files and load it up into your application. Now let's have a look at how to deploy it with Hardhat. There are primarily three ways to do it. In the old days, we either write vanilla Hardhat scripts with a runtime API, or use Hardhat deploy plugin to track deployment states for us. Both of these two ways are imperative, meaning that it usually takes us extra efforts to really make it robust and idempotent. More recently, Hardhat introduced their own declarative deployment system called Ignition, aiming to solve many of these pain points. The core concepts to get yourself started in Hardhat Ignition are module and future. Module is composed of futures which represent the result of execution steps. There are different kinds of futures predefined corresponding to different intended actions. The most common one is contracts, corresponding a transaction of contract deployment. One of the highlights is that Ignition will manage dependencies among these futures implicitly for you, so that we don't have to give too much thought about the exact order of transactions as in imperative ways. Another considerate design is that deployment-related parameters are actually decoupled from deploying logics and maintaining separate JSON files, which improves reusability greatly. In this example, I deploy two contracts, lock and lock v1 with contract futures. Read unlock time property from v1 with that call future, and deposit into v2 with call future. Now let's see this in action. Here I'm just gonna grab a simple contract, modify it a bit, and make sure all the tests have passed. Do remember to update your private key in the .env file. Here is the module definition we've mentioned earlier. Let's modify the initial locked amount. Now we can just execute the deploy command. To verify our newly deployed contracts, we also have some options here. You can verify manually on our Explorer interface, which may cause a bit of hassle if you have many contracts. It can make our life easier by using a plugin like Hardhat Verify that automates the process for us. More conveniently, since Ignition already have this plugin baked in, we can either do it with deploy subcommand by adding verify flag, or separately with verify subcommand. Now we can see our contract has been verified. That wraps up today's video, and thanks for watching.